Hi friends, today we are going to learn power amplifier and its performance parameters. Power amplifier. What is a power amplifier? Power amplifier is an electronic device which boosts the input signal, which boosts the power level of the input signal. As you see in this diagram, fixed signal is applied as an input and there is an amplifier which amplify the signal, and its amplified signal is applied to the output of the signal. What does power amplifier do? Power amplifier adds energy from power supply to boost the signal. Exactly what does it do? Let's imagine there is a crowd of people. Let's imagine there is a crowd of people and a speaker and a person is speaking. Its voice is so soft. Everyone can't hear his voice. So he needs a speaker through which his voice can spread over all the hall. So he uses speaker, and a speaker does the amplification of this voice. It's the use of power amplifier, that it boosted the input signal and make the weak signal stronger. Why there is a need of power amplifier? Let's see, our microphones, sensors, preamplifiers, they produce power of 1 watt or in few milliwatts. If we want a strong signal, we need more than 1 watt or in kilowatts. Power amplifier has 5 types: Class A amplifier, Class B amplifier, Class AB amplifier, Class C amplifier, Class D amplifier. So this every amplifier, every type of amplifier has its different advantages, characteristics and applications. Every has their different applications. So there are various performance parameters of power amplifier. Gain is how much an amplifier increases the strength of a signal. Gain is denoted by A. Gain is denoted by A. Gain is denoted by A. Gain is expressed in dB. It is expressed in dB. dB, it means decibels. What does it mean? Decibels. So, ratio of output power to the input power. There are 3 types of gain. Voltage gain, current gain and power gain. Power gain is used in power amplifier, and power amplifier is defined as the ratio of output power signal to the input power signal. So it has its own formula that power gain is equal to P out by P in. This is the formula of gain. And another parameter is bandwidth. So I give you an example. अगर आपके घर में रेडियो चला रहे हैं, गाना सुन रहे हैं, or you are in a certain on a certain channel like 98.6 megahertz, वो चैनल की रेडियो आपके पर्टिकुलर एरिया में ही है, वो पूरे यूनिवर्स में तो नहीं है ना. मीन्स वो चैनल सिर्फ आपके पर्टिकुलर रेडियो के पर्टिकुलर एरिया में चलेगा. सो इट हैज़ इट्स ओन लिमिट, bandwidth. This is known as a bandwidth. Bandwidth is the space of frequencies an amplifier can handle properly without losing the strength. The range of frequencies over which the amplifier can operate effectively without significant loss in performance. Bandwidth has its own formula. High frequency minus low frequency. It is the difference between high frequency and low frequency. So, frequency response of power amplifier. It is the graph shows that gain versus frequency. The graph shows that gain versus frequency. So let us see that gain and frequency. The gain versus frequency. So this is the graph. Here is F, L, and here is F, H. So where these two are the cutoff points where the gain reaches to 3 dB. When the gain reaches to 3 dB, the cut off there are cutoff points. The above flat portion is a useful bandwidth. It is a useful bandwidth. And the frequency ratio is this is the frequency response. Efficiency. Efficiency tells how much a DC power from supply is converted into AC power delivered to the load. Let's imagine I gave 100 watt to the amplifier as input. But the output is 40%. Where is 60%? The 60% is heat, which transistor heated. So the efficiency is 40%. Efficiency is 40%. So there is a formula of efficiency, that is efficiency is equal to AC output power to the DC input into 100%. So this is the efficiency. Distortion. What does distortion mean? Let's take an example. So if I am singing a song with a mic, and my voice is exactly same while singing a song in a mic, so there is no distortion. But when I am singing, the voice is breaking, the voice cuts, so there is distortion. This is known as distortion. Means distortion is unwanted changes. Distortion is unwanted changes happens in the output signal. Unwanted changes happens in the output signal. So let's see the graph first. The blue color shows that this is pure sine wave with no distortion. This is given as input. But while performance, their amplitude distortion is occur, means there happen a clipping process. clipping processes happen in red color wave, and in green color wave there is a harmonic distortion, means there is the extra frequencies are added. In the fourth wave there is a phase distortion happened. What happened? Phase distortion means the phase has changed, the position of phase is also changed, and in the frequency distortion the frequency is changed, amplitude varies with frequency. These are the types of distortions. So thank you guys for hearing me.